If you ever stood on a railway platform and felt the ground tremble before you saw anything, if you gripped the railing of a bridge while something vast and iron passed beneath you at full speed, if you pressed yourself against a station wall as a locomotive, the size of a building filled the air with white steam and the sharp smell of hot metal, you already know what Baldwin made. That smell, coal smoke and machine oil, and something hotter underneath, something close to burning iron. That sound, not a clatter, not a roar, but a rhythmic, enormous exhalation, as if the earth itself was breathing. That weight, 6 tons, 12 tons, 60 tons, moving through the landscape with a certainty that made everything around it seem temporary. For more than a century, the machines that made that feeling were built in Philadelphia, Pennsylvania. Their builder's plate read Baldwin Locomotive Works, Philadelphia, PA. At its absolute peak, in the year 1906 alone, Baldwin produced 2,666 steam locomotives and employed more than 18,000 workers across its facilities on North Broad Street. By 1906, the company had built engines for railways in Russia, Central Europe, Australia, South America, Cuba, Japan, India, Egypt, Haiti, and dozens of nations that would be familiar to anyone who rode a train anywhere in the industrialized world. In 125 years of continuous production, the men and women of Baldwin built more than 70,500 locomotives, more than any other institution in the history of the world. They survived the panic of 1837, when production collapsed from 40 locomotives a year down to 9, and the company nearly dissolved into debt. They survived the panic of 1857, which cut their output in half in a single season. They survived the American Civil War, which overnight eliminated nearly 80% of their customer base when the southern states seceded from the Union. They rebuilt, they finding their footing again on Union ground. They survived the panic of 1907, the catastrophic labor strikes of 1909 to 1911, and the long, miserable contraction of the First World War's aftermath. They survived a full bankruptcy filing in February 1935. They rebuilt, they merged, they retooled. And then, after more than a century of making, after more than 70,000 machines sent out across the railways of the world, the name Baldwin was erased. Not by a single catastrophe, not by one enemy, but by a sequence of decisions made at the top of the company, and by one technological choice in particular that management refused to take seriously until it was far too late. How does the greatest locomotive builder in history end up fighting for its own survival against an automobile company from Michigan? And what really happened inside the walls of that 600-acre plant in Eddystone, Pennsylvania, in the final years? Before we go any further, if you're finding this story compelling, leave a comment below and let us know what you already knew about Baldwin Locomotive Works. If this is the first time you've heard the name, that matters too. Tell us where you're watching from. And if you haven't subscribed yet, do it now. This is the kind of history this channel was built for. Matthias William Baldwin was born on December 10th, 1795, in Elizabethtown, New Jersey. He was the youngest of 5 children born to William Baldwin, a carriage builder, a man of modest prosperity who had carved out a respectable trade in a young country. Then William Baldwin died. Matthias was 4 years old. The family assets that William left behind were, according to the historical record, systematically mismanaged by the executors of his estate. By the time the legal proceedings had run their course, the widow and children had been left in what contemporaries described as difficult financial circumstances. The fortune that a carriage builder had assembled over a working lifetime was gone. What remained was the mother's determination to see her youngest son educated. From an early age, the boy took things apart. He dismantled his toys not to destroy them, but to understand how they held together. He turned his mother's rooms into workshops. The neatness of his repairs and reconstructions was, people noted, unusual. Even then, the workmanship was meticulous. At 16, he was apprenticed to a jeweler in Frankfort, Pennsylvania. He learned to work with small things, tiny tolerances, precious metals, the discipline of exact fit. By 1817, he had moved to Philadelphia to work for Fletcher and Gardner, an extensive manufacturer of jewelry on Chestnut Street. He became one of their most valued craftsmen. He was not content with imitation even then. The orders that required precision and invention found their way into his hands. But the jewelry trade in Philadelphia suffered a sudden and unexplained collapse in demand around 1825. Baldwin needed a new field. He formed a partnership with a machinist named David Mason at a small workshop on Davis Alley near Chestnut Street in Philadelphia. They manufactured bookbinding tools, then printing cylinders. Then, because neither a bookbindery nor a textile printer can function without power, Baldwin needed a steam engine. He could not find one powerful enough. He designed and built his own. In 1831, Franklin Peale, proprietor of the Philadelphia Museum, asked Baldwin to construct a miniature working locomotive for exhibition. Baldwin had access only to imperfect published descriptions and rough sketches of the locomotives that had competed at the Rainhill trials in England 2 years earlier. He had no templates, no complete drawings. He built it anyway. The model pulled carriages with 4 passengers around a circular track inside the museum. It worked. The crowds were transfixed. The Philadelphia, Germantown, and Norristown Railroad took notice. They needed a full-scale engine. Would Baldwin build one? He agreed. He moved his assembly operation to larger premises near the Philadelphia city limits. He subcontracted the manufacture of the larger parts he could not yet handle in his own shop. And within 6 months, working from those same imperfect descriptions with jeweler's hands now gripping forge hammers, he assembled the machine that would become the first of more than 70,000. The locomotive Baldwin delivered to the Philadelphia, Germantown, and Norristown Railroad had a name before it had a formal designation. People looked at the iron bands wrapped around its wooden driving wheels, and they called it Old Ironsides. Its wheels had heavy cast-iron hubs with wooden spokes and rims wrapped in wrought-iron tires. The boiler was 30 inches in diameter. It needed 20 minutes to raise enough steam to operate. The cylinders were 9.5 inches by 18 inches. The entire machine weighed 6 tons. On November 23, 1832, Old Ironsides was placed on the track for the first time. The United States Gazette reported the next day, A most gratifying experiment was made yesterday afternoon on the Philadelphia, Germantown and Norristown Railroad. In that 6-mile run between Philadelphia and Germantown, old Ironsides hauled a 30-ton load at 28 miles per hour on a level surface. Baldwin's own reaction to this success was, by his own account, complicated. He had built the locomotive under extreme difficulty. The work had exhausted him. He was reported to have said when it was finally out of his shop, "That is our last locomotive." He had no intention of making more. The railroad's owners disagreed. There were technical drawbacks in old Ironsides. The wrought iron tire arrangement was not entirely satisfactory. But the machine worked, and it proved that American-built locomotives could replace the expensive, heavy British imports that the new railways had been relying on. Baldwin did not stop at one. He never stopped. By 1835, he had received engine requests from the Hudson and Mohawk Railroad and from the Commonwealth of Pennsylvania for its state road. He moved the company to new manufacturing facilities at Broad and Hamilton Streets. By 1837, the company employed 300 skilled artisans and was producing 40 locomotives a year. The work's progress moved in tandem with the explosive expansion of American railways. All the systems of large-scale industrial production were being invented as needed. The logistics of raw material supply from Pennsylvania's coal and iron mines. The design and manufacture of specialist tools. The management of hundreds of men working in coordinated shifts. Then, in 1837, the financial panic hit. Production collapsed. From 40 locomotives a year, the company fell to 9 in 1840. The firm was heavily in debt. Creditors pressed from every direction. Matthias Baldwin did not close the doors. Instead, he negotiated openly with those creditors. Frank conversations described in contemporary accounts as honest to a degree unusual in the business culture of the time, and took on 2 new partners, George Vail and George Hufty, to bring in the capital needed to survive. The partnerships were short-lived, but they held the company together through the worst of it. He rebuilt. By the 1850s, railroad construction had become a national obsession, and Baldwin had become the dominant American builder of locomotives. The company employed between 400 and 600 men. In 1857, it turned out 66 locomotives. In that same year, the Panic of 1857 struck, and output fell by 50% the following year. They rebuilt again. By 1860, 80% of Baldwin's business depended on Southern railways. When the South seceded from the Union in 1861, that business vanished almost overnight. Production fell by more than half in a single year. Baldwin considered converting the factory to manufacture shells and shot. But the Union Army and the Pennsylvania Railroad stepped forward with locomotive orders, and the company found its footing again on Union ground. This was Baldwin's pattern: crisis, contraction, survival, expansion, repeat. The question that matters, and that this story will answer, is why eventually that pattern broke. By the 1870s, 4 years after the death of Matthias Baldwin himself on September 7, 1866, the company he had built from a jewelry shop on Davis Alley had become by far the largest locomotive producer in the United States. It was not even close. The plant on North Broad Street in Philadelphia occupied more than 200 acres of buildings and yards in the heart of the city. The sound of it carried for blocks, the percussion of metal on metal, the hiss of steam from the test bay, the grind of lathes and presses, and the voices of thousands of men in a continuous industrial conversation that ran from first light to last. The workers who came to North Broad Street came from everywhere. First the German and Irish immigrants of the mid-19th century, then the Southern and Eastern Europeans who arrived in the great wave of immigration at the turn of the 20th century. Poles, Italians, Russians, Ukrainians. Most arrived without industrial skills. The works trained them. Apprenticeships at Baldwin lasted 4 to 5 years. Parents wrote letters to the company according to the historical record of the works correspondence, requesting places for their sons. "Desire to get their children in this business," one correspondent wrote. 3 generations of the same families worked at Baldwin. A grandfather who had arrived with nothing from County Cork. His son, a boilermaker. His son's son, a machinist in the erecting shop, fitting driving wheels to frames, torquing bolts to the thousandths of an inch that the tolerances demanded. The works were not just an employer. They were a social fact. The neighborhood around North Broad Street organized itself around the rhythms of the plant. The shift changes, the paydays, the occasional strikes, the moments of collective pride when a particularly large order went through. At the peak of production, between 1898 and 1906, Baldwin was exporting locomotives to Russia, where 138 engines went in 1895 and 1896 alone to stabilize the company after the panic of 1893, to Australia. To Japan, the first railway locomotive to operate in Japan arrived from Philadelphia, and the Japanese took their first train ride on a Baldwin engine. To Central Europe and South America. By 1906, the works were producing engines for railways on every inhabited continent. That year, 1906, was the year the numbers peaked. The works employed more than 18,000 people. They produced 2,666 steam locomotives. More than 7 a day, every week, every month of that calendar year. Shifts running around the clock to keep pace with the demand that seemed to those inside the plant like it could only grow. The locomotives Baldwin produced in this period were not crude machines. The company had been refining its designs for 7 decades. The bogie, the movable truck that balanced a locomotive on curved track, had been a Baldwin adaptation from the earliest years, because American track was less precisely laid than British track, and locomotives needed flexibility to stay on the rails. During World War I, the full scale of what Baldwin had become was made visible in the most dramatic terms imaginable. When the European powers went to war in 1914, their domestic manufacturing was immediately redirected to armaments. The Allied nations, Britain, France, Russia, needed locomotives. The railways behind the Western Front were the circulatory system of the war, and those railways needed engines. They turned to Philadelphia. Baldwin built 5,551 locomotives for the Allies during the war. Engines designed specifically for Russian gauge, engines for the French trench railways. engines for the standard gauge British supply lines, and 465 more for British main lines. The volume of orders exceeded the capacity of the North Broad Street plant, so Baldwin constructed new facilities 12 miles south of the city, on the Delaware River waterfront in Eddystone, Pennsylvania. The Eddystone Arsenal, a subsidiary of Baldwin Locomotive Works, produced artillery shells for Russia, Great Britain, and the United States. Total production: 6,565,355 shells. In the same complex, under subcontract from Remington Arms, Baldwin built a 14-acre rifle plant, the largest rifle plant in the world during the First World War, and employed 15,294 workers there, with women accounting for 20% of the peak workforce, manufacturing up to 6,000 pattern 1914 Enfield rifles per day. Almost two-thirds of the rifles carried by American soldiers in France in 1917 and 1918 were made at Eddystone. The company was now, quite literally, arming a world war. The danger was not visible from inside the plant in 1920. Not clearly, not yet. The Eddystone plant that had been built to manufacture shells and rifles was converted after the armistice into a locomotive manufactory. By 1928, the company had moved all locomotive production from the old cramped 200-acre site on North Broad Street to the new 600-acre facility on the Delaware River. It was the most modern locomotive plant in the world. The man who made that decision, who championed the Eddystone expansion when others in the boardroom opposed it, was Samuel Matthews Vauquelin. Vauquelin had come to Baldwin in 1880 at the age of 24 as a locomotive inspector sent by the Pennsylvania Railroad to examine the works. He had trained in the machine shops of the Pennsylvania Railroad, and the work had left a permanent mark on him. Years of chipping and filing metal by hand had left his hands in a permanent clutching position, the fingers curved and stiffened by the labor. Vauquelin was a genuine engineer. His name appeared on the Vauquelin compound locomotive, a design that used steam twice, expanding it through 2-cylinder stages to extract more work from each pound of coal. He had received the Distinguished Service Medal for his role in arming the United States Army during World War I. He was a serious man who had built serious things. He was also catastrophically wrong about the future. In 1930, in a speech that was widely reported, Vauquelin stated his conviction that advances in steam technology would ensure the dominance of the steam engine until at least 1980. In December 1937, Baldwin's vice president and director of sales added his own prediction. Sometime in the future, when all this is reviewed, it will be found that our railroads are no more dieselized than they are electrified. General Motors, through its electromotive division, based in LaGrange, Illinois, had come to a very different conclusion. Through the 1930s, while Baldwin was moving all of its capital and its entire manufacturing infrastructure to a new plant designed to build steam locomotives at even greater volume, Electromotive was developing a standardized, mass-produced diesel-electric locomotive that could be built efficiently on an assembly line, shipped to any railway in the country, and maintained without specialist knowledge. What almost nobody knew at the time, and what the history books have been slow to examine closely, was that General Motors had actually explored the possibility of a partnership with Baldwin Westinghouse in the late 1920s. According to forum accounts from historians and former Baldwin employees compiled in the 1980s, Vauquelin had been nominated to the board of directors of Fisher Auto Body, a General Motors subsidiary, in 1929. The works emerged from the 1935 bankruptcy filing in 1938, restructured but diminished. Sales of steam locomotives had dropped from representing 30% of the domestic locomotive market to barely 2% by 1940. The Eddystone plant sat at less than 1/3 of its production capacity through most of the 1930s. In 1932, Baldwin produced exactly 6 locomotives. 6. The same plant that had sent 7 locomotives out every day in 1906 now produced 6 in a full calendar year. The first crack had become a fissure, and the fissure was about to become a collapse. Chapter 5. The villain enters. Electromotive, Westinghouse, and the decision that killed Baldwin. By the time Baldwin's management fully accepted the future was diesel-electric, the race was already over. In 1935, the year Baldwin entered bankruptcy, General Motors' Electromotive division demonstrated its EA passenger diesel and was preparing the FT road freight diesel for mass production. The FT would prove, on a national demonstration tour in 1939 and 1940, that a diesel locomotive could outperform steam in every measurable category: fuel efficiency, maintenance costs, availability, and reliability over long periods. When Baldwin emerged from bankruptcy in 1938 under new management, the company finally began to develop diesel locomotives on a larger scale. But even this renewed interest was almost immediately blocked by the outbreak of the Second World War. The War Production Board authorized Baldwin's main competitors to build diesel locomotives. Baldwin was directed to continue producing steam locomotives for military and Allied railway needs. Baldwin was limited in its diesel development to the VO660 and VO1000 switcher models. These were switchers, not road locomotives. There was a specific problem with the VO engine that Baldwin's engineers knew about and were unable to fix. By then, those defective engines had gone out to railroads across the country. They had established Baldwin's reputation in diesel as unreliable. That reputation was extraordinarily difficult to undo. Then, in 1948, Westinghouse Electric, which had supplied electrical equipment to Baldwin since the 1890s, acquired a controlling interest in the company. This is the specific decision that most historians of Baldwin point to as the point of no return. Westinghouse control came, ironically, at precisely the moment when Baldwin's management had finally become serious about competing aggressively against EMD and Alco. Westinghouse did not share the philosophy. They insisted that only Westinghouse equipment be used, preventing Baldwin from updating its control systems. The equipment was gradually becoming obsolete compared to what EMD was using. In September 1951, Baldwin merged with the Lima Hamilton Corporation to form Baldwin Lima Hamilton. Lima Locomotive Works of Lima, Ohio, had its own distinguished history of steam production. It had built the famous superpower locomotive designs of the 1920s. and was in the same position as Baldwin, a great steam builder caught on the wrong side of a technological transition. The merger combined two declining companies. It did not create one healthy one. Under the Baldwin-Lima-Hamilton banner, diesel production continued modestly into the mid-1950s. The S12 switcher, 451 units built between 1951 and 1956, was a reliable machine. But sales remained low. In 1955, BLH ceased diesel production. In 1956, it delivered its final locomotive, a diesel switcher, to the Kaiser Bauxite Company in Jamaica, and exited the locomotive market altogether after 125 years of continuous production. The detail that was not widely reported at the time was that this final delivery was not the conclusion of a planned withdrawal. It followed the loss of a specific, significant contract to EMD. That one lost deal was the last straw. The locomotive business was abandoned. The years between 1945 and 1956 were not a single event. They were a sequence of specific decisions, each one closing off a possible escape. In 1945, Baldwin's management had a choice. They could invest heavily in diesel research, accept short-term losses, and compete on quality and price. Or they could try to sell as many steam locomotives as possible while domestic demand lasted, and hope that diesel was still a decade away from dominating the market. They chose a version of the second option. By 1946, it was already too late to choose differently. The workforce at Eddystone felt the change before management announced it. Machinist William Draper, who worked in the erecting shop from 1941 to 1953, recalled in a 1981 interview with a Chester County newspaper that you could feel the orders drying up. In 48-49, we'd have gaps in the erecting bay where there used to always be a locomotive under construction. Just empty floor space. The empty floor in the erecting shop was the visible measure of the company's competitive failure. When Electromotive delivered its FT demonstrator to various Class I railroads in 1939 and 1940, the results were humiliating for steam. The FT crossed the Rockies without helpers, something steam locomotives needed. It ran in multiple unit configurations, 2 or 3 units coupled together and controlled by a single engineer. It required dramatically less maintenance. The railroads were persuaded. Orders flowed to Lagrange. Manufacturing decisions compounded the problem. The Eddystone plant had been designed and built specifically for steam locomotive production. The erecting shop floor, the overhead cranes, the layout of the machining areas, all of it had been optimized for a product that required different manufacturing methods than a diesel-electric locomotive. Where EMD could build F units on a car body assembly line, moving locomotives through stages the way Ford moved automobiles, Baldwin's diesel production was still essentially a craft process. Each locomotive was assembled by a team. This produced high-quality individual machines. It could not compete on cost. By 1952, the Eddystone plant was operating at a fraction of its capacity. The 600-acre facility, built to produce thousands of locomotives a year, was producing dozens. Men who had been with the company for 20 years found their departments consolidated, their colleagues transferred or let go. There were no mass layoffs announced in headlines. The decline happened through attrition, retired workers not replaced, departments that had once occupied an entire building consolidated into a corner of a floor. By 1955, the locomotive workforce at Eddystone had fallen from the wartime peak of more than 15,000 to a number that plant management declined to publicize. Former employees who were interviewed by historians in the 1980s and 1990s gave figures ranging from a few hundred to a few thousand in the final year of locomotive production. The plant that had armed a world war now produced construction equipment. The records, when locomotive production ended in 1956, were not preserved. The majority of Baldwin Locomotive Works records and engineering drawings were disposed of when production ceased. What little survives today, according to the Commonwealth of Pennsylvania's own archival research guide, is the result of quick and random action by former employees and enthusiasts who literally rescued materials from the company's wastebaskets. Private collections hold scattered drawings, correspondence, builders' photographs. The formal archive was destroyed. This fact alone tells you what the company's management thought of its own history at the end. It was not worth keeping. The last Baldwin locomotive left the Eddystone plant in 1956. It was not a ceremonial occasion. There was no public announcement of significance. The final unit, a diesel switcher destined for the Kaiser Bauxite Company in Jamaica, was completed, tested, and shipped without the kind of recognition that 125 years of continuous production might have warranted. The men who worked in the final weeks knew it was the end. The orders had stopped coming. The company was pivoting to heavy construction equipment. The locomotive division was over. One account from a former erecting shop foreman described the atmosphere in the final weeks as very quiet, not angry, just quiet. Men doing their work, not talking much about what was happening because we all already knew. The Eddystone plant did not close immediately. Under Baldwin Lima Hamilton, the facility pivoted to manufacturing cranes, excavators, and other heavy construction equipment. The BLH name appearing on the boom of a crane the way it had once appeared on the driving wheel of a locomotive. In 1965, BLH was sold to Armour and Company as a wholly owned subsidiary. When the Greyhound Corporation acquired Armour in 1970, they inherited BLH along with it. In 1972, Greyhound closed Baldwin Lima Hamilton for good. Clark Equipment Company purchased the facility and continued producing construction equipment there until December 1980. Parts production continued until July 1981. In August 1981, a Pennsylvania salvage company owner named Joe Kowalczyk bought the property for approximately $2.1 million. A newspaper reporter who walked through the Eddystone buildings in October 1981 wrote, "A profound silence fills a cavernous room where once hundreds of men shaped iron into steam locomotives. The lingering smells of well-oiled machines and smoldering metal serve as a reminder of bygone days. All that remains today are inventory-tagged tools and machines, occupying what are soon to be vacant buildings." The smell was the last thing to leave. In May 1994, demolition of the Eddystone plant began. Over a period of 53 weeks, just over a year, the buildings were taken down to clear the land for development. The erecting shop, the boiler shop, the machine shop, the test bay, the offices where Samuel Vauquelin had made his decisions, all of it removed, acre by acre, from the Delaware River waterfront. What we know is this. The men who had built steam locomotives had skills that were not transferable to a world that ran on diesel-electric power. A boilermaker who could build the firebox of a 484 steam locomotive had expertise of extraordinary depth and precision, but there was no market for that expertise in 1956. Some found work in heavy manufacturing. Some retired early if they could afford to. Some, particularly those who had been at the plant for 30 or more years, found the transition to other employment genuinely difficult. The question posed at the beginning of this documentary was not simply how Baldwin failed. The question was what really happened inside those walls. Here is the answer. Baldwin did not fail because of globalization or market forces or the inevitable march of progress. Those explanations are too comfortable. They distribute blame into abstraction and allow specific people to escape examination. Baldwin failed because of a sequence of identifiable decisions made by identifiable people. Samuel Vauquelin's decision in the 1920s to move all production to Eddystone on the assumption that steam would grow forever. His repeated public statements in 1930 and later foreclosing internal debate about diesel technology by making his personal conviction into company policy. The War Production Board's wartime restriction, a government decision, not a market one, that forced Baldwin to keep selling diesel engines with known mechanical defects, poisoning its reputation in the diesel market before it could properly establish one. Westinghouse's acquisition of a controlling interest in 1948 and its insistence on locking Baldwin into Westinghouse electrical equipment, preventing the improvements that might have made Baldwin diesel locomotives competitive. Each of these was a choice, made by a specific person, in a specific year, with specific consequences that could be traced forward through time. The irony at the heart of Baldwin's story is the most painful kind. The company's greatest strength, its absolute mastery of steam technology, accumulated over 125 years and represented in the skills and institutional knowledge of its workforce, became the reason it could not adapt. The investment in Eddystone, the 600-acre plant that was the physical monument to Baldwin's dominance, was built for steam. To compete in diesel, the company would have had to walk away from that investment. And men who had spent decades building something do not walk away easily. Samuel Vauquelin's hands had been permanently deformed by years of filing metal in a machine shop. He knew what it was to make things. What he could not accept was that the things he knew how to make were no longer the things the world needed. Today, the site of the Eddystone plant is largely cleared land and generic industrial development along the Delaware River waterfront south of Philadelphia. The X-shaped water tower that marked the plant's location, visible for miles to anyone traveling the rail line or the river, still stands, a landmark without a monument. The long building on the south side of the former rifle plant is now occupied by Aero Aggregates of North America, a manufacturer of lightweight fill materials. Where thousands of women once assembled Patton, 1914 Enfield rifles, a company now produces recycled glass aggregate. The North Broad Street site in Philadelphia, where Matthias Baldwin first built at scale, at the corner of Broad and Spring Garden, is today Matthias Baldwin Park, a public green space established in recent years to mark the history of the place. A Pennsylvania historical marker at the northwest corner of the park acknowledges what stood here. The marble statue of Matthias Baldwin himself, which stood at Broad and Spring Garden from 1905 to 1921, was moved to a corner of Philadelphia's City Hall, where it stands today in what one historian described as a little noticed nook. The locomotives themselves, those that survived, are scattered across the world. The Franklin Institute in Philadelphia holds Baldwin No. 60,000, a 410-2 steam locomotive built in 1926 as the company's 60,000th commemorative engine. It took crews 5 days to move the locomotive into the museum's train factory room in 1933, and it has been there ever since. The Railroad Museum of Pennsylvania in Strasbourg holds several Baldwin-built machines, including working survivors that still carry the builder's plate. The Steamtown National Historic Site in Scranton operates a Baldwin 060 switcher from 1929 under steam. Preserved Baldwin locomotives exist in museums and on tourist railways across the United States, India, China, Australia, and South America, in countries whose railways Baldwin once dominated as the supplier of first choice. The records that survived, the drawings, correspondence, and engineering documents that escaped the wastebaskets of the Eddystone plant, are held at the DeGolia Library at Southern Methodist University in Dallas, at the Historical Society of Pennsylvania, and at various smaller collections. They represent a fraction of what existed. The rest is gone. The coal industry, it should be noted, played a role in Baldwin's resistance to diesel that is rarely acknowledged. The coal companies were major stakeholders in the political economy of steam. They supplied the fuel that steam locomotives consumed in vast quantities. A railway that dieselized was a railway that stopped buying coal. The coal industry lobbied, informally and formally, against the dieselization of American railways. Baldwin, deeply embedded in the Pennsylvania industrial complex that centered on coal and iron, was not immune to those pressures. The resistance to diesel was not purely a matter of management arrogance. It was also a matter of whose interests management had internalized as their own. Was it Samuel Vauquelin's fault? Partly. Was it Westinghouse's acquisition strategy? Substantially. Was it the War Production Board's allocation decisions? Significantly. Was it the railroad's preference for EMD standardization, once established? Critically. Was it the coal industry's political influence on a company that had grown up in its orbit? Plausibly. There is blame enough here for many hands, and the honest accounting requires that it be distributed rather than placed on a single villain. What cannot be disputed is this: the workers of Baldwin Locomotive Works, the machinists, the boilermakers, the pattern makers, the erecting shop hands, the men who checked the tolerances on driving wheels with instruments more precise than anything that existed when Matthias Baldwin was alive. Those workers did not fail. They made what they were asked to make, with a skill that had been accumulating for 125 years. They were not given a machine they could not build. They were given decisions they had no power to change. The Pennsylvania Historical and Museum Commission placed its historical marker for Baldwin Locomotive Works on September 26, 2009. The dedication ceremony was quiet. There were former employees present and their children, and people who simply cared about what had been built on that ground. They stood around a green metal sign and remembered a machine that once made the earth shake. We are now asking you to do something similar. If you worked at Eddystone or on North Broad Street, if your father carried a Baldwin toolbox, if your grandfather came home smelling of machine oil and coal, write it in the comments below. Tell us what you remember. Tell us what country you're watching from. Tell us what in this story surprised you most, or what you already knew that we haven't said. The knowledge is in the workers. It always was. And it deserves to be spoken before it's gone.